Next up at GroupBy, we have Tracy Boggiano talking about collecting performance metrics with open source software. Take it away, Tracy. And I'm going to pop off camera because I have to go finish getting ready the kids for school.
All right, so let's get started. So this is my presentation on using open source software to collect performance metrics, specifically with SQL Server, but a few other platforms as well. I'm Tracy Boggiano. I'm known as a database superhero. I work at a company called FM Systems in Raleigh, North Carolina that deals with the facility management space. I have finally hit the 2.0 mark of experience with SQL Server for 20 years. I know that makes me sound really old, but I'm really not. Last year, I was an Idera ace, so I got to do a lot of cool presentations all over the United States and over in Europe, and they named me an Idera superstar for the year, which they turned me into a duck picture. So, and along with 8 other people. I also lead a advanced DBA group here in Raleigh for advanced DBA topics like level 300 through 500 that you would see at Past Summit. I also lead getting other Linux content into the existing virtual groups for Past. I'm a founder of WeSpeakLinux.com, where we try to get sessions for Windows admins to help them learn Linux and SQL admins to learn Linux because a lot of stuff is going Linux. I'm a member of SpeakingMentors.com, where we're trying to mentor more people into becoming speakers and doing webinars and speaking at local user groups and things like that. And I also volunteer with the Abused and Neglected Foster Children through the Guardian Ad Litem program here in North Carolina, or known as CASA nationwide in the US. So that takes up a good majority of my time. So I don't really have time for anything else after all that. So alone work. So now we'll go over what we're going to actually cover in this webinar. We're going to go over why we would want to collect performance metrics, when we would want to collect performance metrics, what performance metrics are going to be collected by this solution that we got, and then the how about how the solution will work. And then we'll go over a demonstration of how I use it to solve a problem on a Saturday morning so I could go back to taking a nap, which is always very important to make sure you have a nap. So the why behind collecting performance metrics is, one is so that you can understand the trends in your environment. So sometimes you need to know if you're have an uptick in CPU over a specific amount of time, means you might need to upgrade or look at tuning something so that you can get that CPU back down, or somebody's upgraded something that's causing a problem, or something's taking up more memory than it used to. So those type of things you need to keep trends on, or your database file size growth, so you know that when you need to add space and what you're projected to do for budgeting and things like that. It's also helpful for finding problems before someone complains. I find it's very useful to keep the VPs and the CEOs and all those C-exec people out of your cubicle. So if you're able to have something collecting performance metrics and you're able to go in there and look at things on a periodic basis or set up alerts based on those metrics, then you're able to find something before someone complains, and you're able to ward off all those unnecessary people coming to your desk going, hey, what's going on type scenarios. And you're going, I don't know. Also allows you to proactively tune things, because you're able to go in there and see when changes are made, what has changed on your system. So you can see that you had an uptick in CPU and go, okay, so something's changed. I need to go and find what changed that's causing the CPU to be higher than normal. Or maybe your page life expectancy all of a sudden starts dipping lower than you want it to on your environment. And so you're reading in more pages into the buffer pool off a disk, so you might need to see if there's an index that needs to be added someplace. Those type of things allow you to be able to do this when you have things set up. It also makes troubleshooting easier. So for one of the times that people do get to you and complain before you're able to see it, you can go back and retroactively see what was happening on the system. By having these metrics available, you're able to go in and troubleshoot and say, yeah, the CPU hit 100 at this particular time, or my PLE tanked to 0 at this specific time, so this may have caused an issue, and let me go see what was running at that time. And I mentioned before a little bit about capacity planning when you're keeping up with how large your environments are getting. When you got 500 servers or a larger real estate, or even a smaller real estate, knowing how much your CPU is being utilized, how much memory is being utilized on your system, how much disk space things are taking up, helps you see how things are growing so that you can capacity plan and do those budgeting type things. And also lets you know, like, if a BI team comes over to you and wants to add a 10 gigabyte database to a server that has a PLE of 60 days on it, true story, I had a lot of memory. then you can get away with adding that 10 gigabyte database to that environment, depending on how much memory was on that server, of course. But it gives you the ability to know these things ahead of time that they're available to you. So more whys is so that you can have what your normal baseline is for performance. So when you're troubleshooting things, you wouldn't know if the CPU being 80% is normal or not if you didn't have a baseline ahead of time. So things you would want to know is what is your normal CPU utilization during a specific time window. It could be at 80% from 8 to 5 during the day if you were like a bank or something, and that was your most utilized amount of time. It could be like that all day long if you were like my last company, you're an e-commerce company, and things are just 24/7. So knowing when your CPU utilization is high and low is important to know. Other things is knowing when your buffer pool and your plan cache are competing for each other for space. And when your buffer pool dips, you're taking pages out of memory and pulling things up off a disk. And then knowing that your plan cache is being bloated up, you need to know these things so you know how well SQL Server is utilized in the memory. And I still keep track of page life expectancy because I don't keep it at 500 like the good old SQL 2000 days recommendations were. But you want to know how long your pages are staying in memory and whether that's a normal rate that it's staying in memory or not. And if you're seeing it dipping lower than normal, hey, something's changed on the system that I may need to look at, especially if it takes a huge dip. It also helps you investigate things that are abnormal in your system. So if you see a sudden increase in CPU of 10% and it just steadily stays that way and nobody says they made a change, somebody made a change. So you got to go and figure out what's running that has made that change. If the buffer pool or the plan cache is higher than normal or lower than normal, you're pretty much know if that's something that just all of a sudden happened, someone else has made a change as well, and you probably need to investigate whether you need indexing done or you need to look at what plans are being put in the plan cache to see why you're getting so many different plans than you used to have. And then if your PLE is lower than normal, you also know you're reading off a disk more, so that's slowing you down. So you need to check into that and see what change might have occurred there. So again, that might involve doing some indexing so you can utilize your data better. So on to the when you would collect performance metrics. I say you collect them all the time. Because if you're not collecting them all the time, then you don't have the ability to see retroactively when something happened. If you're only collecting them during specific times to get a baseline, then you only have it for that specific time. You don't have a history. And I think you need all that historical reference. With the solution that I'm using, we're collecting intervals at as regularly as 30 seconds, and I've even went as low as 10 seconds on the intervals on an environment that had 500 servers, and it was able to keep up with it. So having that data at that granularity helps you with troubleshooting. So on to what systems we would want to collect our metrics on. Production, of course, is our most important system, so we definitely want to be collecting our metrics on there so that we can troubleshoot production. But test is production to our developers, and also where they're testing everything and their changes, and that's how you would know if a change is going to help your production environment or not. So I would vote you.
That one right there, it hits so many people. They forget that developers need a system that works, and they need to know what happens, right?
Yes.
I hate, that gets me. Thank you for mentioning that.
It drives me crazy to go, okay, well, did you test? And it's like, well, I don't really have an environment that's suitable to test in, and I can't see any metrics in it, and because people only buy, software to monitor production, so.
Right. Yeah.
I set everything everywhere, so yes. In short, the answer is collect your metrics everywhere on all of your systems. Make your developers just as happy as your customers. They're your other customers.
Absolutely.
So now on to how we're going to collect our metrics with this solution. There's a couple of things that I use to go along with the open source software so that I get what queries we're running, because the open source software is mainly perfmon data and DMDs. So we'll go over a couple of those things that will help you troubleshoot things going forward, because you will have that data available to you. One probably everybody has heard of is SP-whoisActive. It's a great stored procedure made by Adam Mechanic. You can find it at whoisactive.com. But it captures what is running on the server currently, And what I do is I set this up to capture into a table like every minute on my servers. And I've had servers that have 30,000 transactions per second running on the server. So it has really no overhead as long as your server has the capacity to, if it can process that many transactions, it can capture this data as well. So you get into a table for later troubleshooting. There's a link to his website. He did a 30-day or 31-day blog post series on it, and day 25 is about how to capture it into a table. So I specifically use these parameters on mine when I capture it. I get all the plans, I get what text is running, I tell it how to format the data, and I get the task info, and then of course tell it what table to put it into. So I like to have the query plan so I can go back in and troubleshoot it there. And by using this, you're able to troubleshoot going all the way back to 2005, because this other solution works on 2005 as well. And because we're good DBAs, we don't want to capture this data forever and keep it forever. So set up a job to clean up this data in this table and don't keep it forever and make a huge DBA database. So my other way of collecting data, you have to be on a more newer version of SQL Server. So that's why I always use SP Who is active in conjunction with Query Store, even when I've got Query Store available, because Query Store rolls everything up into aggregated time intervals. So you can have stuff aggregated into an hour-long interval or 15-minute intervals or 1-minute intervals. I don't recommend the 1-minute intervals. It hoses up your system pretty good. I tried that on test just to see what it would do. But with SP is active, you get everything that's actually running individually instead of an aggregated amount. But with Query Store, you're able to do a few things that'll help you out with performance that you're not able to do anywhere else. So we'll talk about those, because those can help you with troubleshooting. So one is you're able to go in and you fix the queries that have regressed in performance. So you're able to go in and view via a chart different plans that have occurred with a particular query and say, hey, this query performs better. Let me tell it to use this plan all the time when it runs this query. You're able to also go in there and identify what your top queries are running on your system that are eating up your CPU or are running the longest or doing the most reads and writes, and tune those, but based on what you see in your perfmon data that you're collecting that needs tuning. So if your CPU is high, you find your top consuming CPU queries and try to tune those and make them better on your system, and you're able to get better performance. It also gives you an audit history of all your query plans for a given query. So this helps you find out if you have a lot of parameterization sniffing going on your environment. If you've got 26 plans for one query, you probably got something going on parameter sniffing. So you might need to look at that and try to clean that up. So, and it also lets you analyze your resource patterns for a particular database across a 30-day or 60-day time period. So you can see in a visible chart what CPU duration it used over that time period. And you can see which day was higher than the other days and drill down on those days and see what's going on. Then in 2017, they introduced a couple of new features. One was you get your weight stats per each query into 23 different categories instead of each individual weight stat. So you can see that this particular weight stat was waiting on a CPU or buffer or I/O. And then you can drill down on those further by capturing your weight stats with the open source tool that we're going to use. Then you got auto plan correction. So instead of you actually telling it what plans to force it to use, and when it finds a regression, it can actually force those plans for you. That way you can just kind of let it fix itself. So we've had at a previous job, we had a very good track record with getting that to work really well in our systems and get us back some CPU. So now we're going to go into the main part of the presentation. Are there any questions so far?
No questions so far.
Okay. I figured that was all pretty basic stuff. So the main part of this.
In your experience, how well are DBAs doing with this?
With what?
Just the logging piece of this. You know, you've mentioned a couple of tools that almost everyone seems to know about. You know, at least in last couple of years, with Query Store and so forth, do you find a lot of people really are starting to use tools well, or is this still just a foreign concept to most?
I find a lot of people love SP is active when they find out about it, but they don't necessarily know that they can actually put it into a table and things like that. They haven't went through like the 30 days worth of blogs to know all the different options that it has, because it's quite the tool to have. So, but I find when I present this to people, they're like, oh, I'm definitely downloading this and doing it.
That's great.
As far as query store, it seems like everybody seems a little reluctant to turn it on.
Okay.
I recently, my new job I just started, they had a consultant that came in like 5 months before I started that recommended that they turn query store on, and a bunch of other recommendations. They didn't do any of the recommendations, but query store was one of them. And so I come in and I basically, you know, in the first couple of days, I came up with a set of recommendations, and then they sent me the consultant's email, and I was like, hey, these look familiar. So we enabled query store, and I was able to actually go in and start forcing some plans and getting some better performance. And I've actually got a chart in this solution that shows you what autoplane correction did on our systems at one company.
That was great. Yeah, I'm not surprised.
What the impact it had on CPU there.
Yeah, just how easily we are okay to fly blind, right? We just kind of go about the day putting out the fires and forget that there are better tools. So
yeah, I'm big on performance and having the data there. And I had a written system one time that just had perfmon data collectors that collected on a system and restarted and stopped them every day just so I'd have perfmon data back in like 2000 and 2003 days.
Yeah,
and then automatically processed them with PAL, so I would have data. And then I had some RML stuff that ran automatically using server-side traces and stuff before we had all this stuff.
Yeah, that's good. All right, keep going. Sorry, as you're talking, I'm thinking about that. So
the main part of the solution that I'm offering up to talk about is Telegraph, which is a open source solution written in Go. But in order to set it up, we've got to have a database. So I'm going to introduce you to a new database besides SQL Server. So we have InfluxDB, which is open source. Everything we're talking about is completely free and open source. So just in case the title of the presentation didn't give that away. But the time series, this is a time series database. So it's optimized for capturing stuff that's timestamped. So basically when you're doing perfmon data, you're coming in at a specific time that you're collecting that data, and you're storing the values that you've collected. So this is optimized for capturing that type of data. So it's really great for storing the monitoring data. And you can track events in there, so you can actually go in and you can downsample the events, you can track the monitored events, you can aggregate them over time, so you can actually roll them up, sort of like Query Store does, into time windows so you can save space. You can add events for like when a change has happened to a system, you can log that change, and then it can actually show up in our next solution as a line on a graph, and you can hover over it and it'll tell you that a specific change happened at a specific time. And then you know, hey, this change happened, maybe that corresponds to why these metrics are starting to look off. So those type of things are neat to be able to have into a timestamp database. So on the front end of Telegraph, we're going to use Grafana to get all our charts. So this just provides us a very detailed graphical interface for getting our data that we've collected. You have the ability to customize any of the charts that are available on the solution. They're just queries behind the scene. So you can actually go in, and it has a GUI for creating the queries, or you can type the queries in yourself. The syntax is a little bit different coming from InfluxDB, but you've got enough samples from mine where you can figure out pretty much how to do it. It's very interactive. You're able to go in and drill down on a specific time period, click and highlight. It'll adjust all the charts on the screen to that specific time period. You're able to add drill down charts into like a specific chart. Like I've got the weight stats in mine rolled up in those 23 categories that Query Store has. And then you can drill down into that chart and see each individual one instead of just the categories. So we will see all that. It also provides you the ability to create alerts. So you're able to set up alerts in there to say when the CPU hits 80% or 90%, send me an email and tell me what's going on with the server, and it'll attach the chart to you. It also, I think, integrates with Slack and a few other things as well as far as sending the alerts. So I haven't played too much with the alerts on there because we usually use another system for alerts on performance data. And I mentioned the ability to link to other charts. That's the drill downs on the weight stats that we had. This is an example of a chart that we did when we turned on Query Store autoplane correction. We noticed on about 80% of servers, we got a 20% performance increase on our CPU using Query Store autoplane correction. And we were just able to go back in time because we had this data. This is a month-long period, a week-long period here, and we could see right in the middle where I upgraded the servers and turned it on that the CPU dropped by 20%, and we were able to go back and check several servers and see that the same pattern had happened. And we actually informed Bob Ward of this, and he made a blog post about it, and he was very happy. So now the main part of the solution that collects the data is WrittenGo, and it's available on GitHub, so anybody can actually contribute code to it. And it actually collects data from more than just SQL Server, and it can output data to more than just InfluxDB. It can actually output the data to SQL Server if you wanted it to. I just find Influx to be pretty quick. Some of the other inputs you have, I'm naming mainly database-specific ones because there's quite a few of them. There's like Cassandra, Docker, InfluxDB itself. We can monitor it. You can monitor the Linux operating system level. So if you have an application server that you want to monitor that runs on Linux, you can monitor that. MySQL, PostgreSQL, Redis, of course SQL Server, or we wouldn't be doing this presentation. And you can monitor Windows at the Windows level. Again, if you got my company uses IIS for their web servers, so I could add the IIS servers in there and watch the processes on there and make charts for those as well. So as far as what data is collecting, we're going to specifically talk about the SQL Server data it's collecting. For Azure DB, it's collecting stuff in the DMDB resource stats. We're also getting our virtual file stats so that we can see our latency on our files. We're getting all our memory clerks so we can see what the buffer pool and the planned cache and what Hekaton's doing and things like that. If you're using any of that stuff, Hekaton's pretty important to monitor. We're getting a lot of the performance counters out of the OS performance counters, not all of them. Those are all documented on the GitHub repository. And of course, we're getting the server properties, like how many databases are there, which ones are offline, online, what version of SQL Server it's running, things like that. And importantly, I think, is weight stats. So there's a lot of other stuff it collects as well. We get resource governor data, you get memory data for PLE and page life expectancy, TempDB usage. You get availability group data to tell you how well your availability groups are performing. It does database mirroring as well. And so all those things are all wrapped up into one little about 40 meg file that you install somewhere and tell it which servers to monitor, and you configure it to tell it, hey, put this in InfluxDB and you're good to go. So we'll go a little bit over the installation of it. I do have a blog post on my website that goes right down the installation of it. I had a friend of mine who's a consultant recently tell me, yeah, I set aside like 8 hours to install this for a gig of mine, and it only took me 2 hours going through your blog. So it really doesn't take long to set up. Once you have the VM set up for the InfluxDB and Grafana, everything's pretty straightforward for installing it. So
that's great.
So it's and I can bring up the blog post to show you what it looks like when we get to the demo side. So, but basically, you would go to their website and use whatever commands for whatever version of your operating system you're using. I'm using Linux for it just so I can get a free operating system out of the deal and go really cheap on this solution. Open source. And so with Linux, though, there's a few extra steps. So I mentioned those because most servers are used to Windows. The service doesn't automatically start, so you'll need to tell it to start. You need it to set it to auto start because we don't have a GUI for doing that. And we have to add the port that InfluxDB communicates across to the firewall. So because the firewalls are all turned on by default in Linux. And then we'll have to create a database, of course, in InfluxDB for it to store our data. And then I set a retention policy so that it automatically cleans out the data after a year. So, and that's just my default settings. There are more settings that you can set where you can roll the data up into like 5-minute chunks, an hour-long chunks after so many days and things like that to help conserve on space and query time to InfluxDB. But all that's outside the scope of this presentation. So installing and configuring Grafana is pretty much the same thing as first steps. Is you got to download it from the operating system, do a few extra steps on Linux. Then we would go into Grafana and add InfluxDB as a data source, and I'll show you how we do that. And then we would just import the dashboards that I've got available on GitHub to see the data, and we will look at how to do that. As far as how to set it up for talking to your SQL Server, we need a login in SQL Server for Telegraph to connect to. So it needs very basic permissions, just view server state and view any definition. With those two permissions, it's able to do everything it needs to do, and you're not giving away anything. Of course, give it a nice, good password besides my strong password, but that one would work as well if it gets past your security people. So As far as downloading Telegraph, you would download it from the nightly builds, because I'm assuming here we're doing it on Windows. I put out the link to the nightly builds. You download the zip file, and what I do is I unzip it onto my network folder, and I set up my config file to tell me what I want, what InfluxDB I want it to connect to. And then I have a PowerShell script, I think, on the next screen that'll allow you to actually install it to any machine you send into the server's parameter, so that you don't have to log into every machine and install it. And then you would set up your config file. So we'll look at the config file. Probably should have had this already open, but I don't.
It's early. I don't know about you. It's been raining for a day here, so we're all having fun watching your cat.
Oh yeah, she's like all over the place. She was all over this desk this morning. I was trying to get a picture of her. She was sitting on it while I was making tea this morning, like she was going to own the desk. So, this is what a config file looks like for Telegraph. A lot of it's just comments, so you know exactly what it's doing. You can have some global tags where you can tell it what domain controller and rack and things is in. I don't use any of that stuff. This is an interval. You can tell it how often to collect the data in. I've just got it set to 30 seconds. All the rest of these that are unhighlighted out, these are just the default settings, telling it to what to batch it up in and what metrics to buffer it in, when to flush it out. One setting sometimes I change is the host name, if I want the host name to be something besides what it returns with the host name parameter. Like Linux returns the whole domain name, so I've gotten used to changing that after the fact. So I didn't have mine plus Hoosiers.local as my domain. Then you have your output clause that tells you which where to write your data for InfluxDB. You're writing out to a URL with a port. Of course, if you give it a DNS name, you can use that as well. I created a database called Telegraph to store all my data in, and so it writes it there. Everything else on here is just default settings. You do have the option to change usernames, passwords, set up SSL to communicate, HTTP proxies, all that stuff's past this presentation. Then as far as the inputs go, you tell it that you're connecting to SQL Server. I just leave it at localhost because I do install it just locally to every SQL Server. And I just gave it real simple passwords, and it's off to the races. Important for my dashboards is to make sure you uncomment out version 2 of the queries. Because if you use version 1, the dashboards that are on my GitHub will not work. And then I also add a couple of little objects down here to get some Windows performance counters, mainly around the processor and how the logical disk is being utilized. So, and you can add any Windows performance counters down here like this. So if there's other ones you want to capture on your SQL Server box that aren't being captured, you can just simply add them in here and they'll be captured going forward. So with that file and the Telegraph exe file sitting on a network share, I take and I use the PowerShell script to just deploy it to a SQL Server. Whoops, we didn't want to start all the way over. Go back down. Sorry about that. Wrong button. But I do have a PowerShell script available that will just put it in your program files on your server on the C drive and create a Telegraph folder. Copy the Telegraph exe and the telegraph.config file over for you, and install the service for you, and tell it that the config file right here is the config file that it should be using. And then stop and start the service for you, and then it's up and running and sending data as long as everything's configured correctly. And we've got it logging, so there's a log file that will be created. So if there's errors, you can actually go in and see the error messages that it's producing. So with this, you're able to install it to 500 servers at once, or when you're just starting, just one server, because you don't want to break all your servers at one time. So getting Telegraph on your SQL Server on Linux, which is the whole reason I started down this path of looking for an open source solution anyways, is because when they came out with Linux, they released these Grafana dashboards collecting with CollectD, but CollectD doesn't run on Windows. So I went out hunting for something that would run on both, and Telegraph would run on both. So I worked with a coworker of mine to help Telegraph run faster. He did most of the work on that because he programs faster in Go than I do. And we ended up getting it cross-platform at that point. And Microsoft has since released a version, did some updates to Telegraph to let it monitor Azure SQL managed instances as well. And we're working on the Azure DB part to improve the dashboard for that. So I've been working on the side on doing that. So just to name some stuff that how I ended up on this solution to begin with. And again, with Linux, we got a few extra steps after we download our exe, our file. We have to create a config file. In this case, we're going to have to edit it so that we can put in the exact name of our InfluxDB that we want to go to, our starter service, and set it to auto start. So now we've got Telegraph installed on all our SQL servers that we want to run it on, and it's sending data in InfluxDB supposedly because we followed the blog article and everything's going well. So now we go into Grafana, and we need a data source to tell us where we're pulling our data from. So we're going to tell it, hey, we're just giving the name of one of our InfluxDB databases. We can name it pretty much anything. We tell it what type. We give it the URL for the server there. And if you've changed any of your admin passwords and stuff like that, you put your database down here because you can name it something besides Telegraph if you don't want it named that. And you save and test it. So that's pretty much all you do there. And I always set the one that's Telegraph as default because I have a separate one for InfluxDB because SQL's my one I'm using the most. And once you save and test it, it tells you whether it's able to connect to it or not, and you know if it's valid. Then the next step in Grafana is actually getting some dashboards in there to actually see the data. So once you're able to do that, you click on dashboards and then import, and you just paste some JSON code into the big box down at the bottom and hit load. It'll ask you to rename the dashboard if you want to. I recommend not renaming most of mine because some of those are linked dashboards into one of the main dashboards. So if you rename them, the links won't work. And then you just load it and all the dashboards will be there. And of course, they're available for download on GitHub. So now let's just go see this stuff in action. Now, I couldn't use my Linux machine for this presentation, so I'm doing this backwards. I'm using TeamViewer to get to my Linux machine.
Excellent.
GoToMeeting doesn't work on Linux.
That's funny.
So I did what I had to do.
It's Inception.
It's like, come on, I can't share anything. So down on the cog wheel, after you log in, you'll have where you can go to data sources. And I've got this made up one that I did for the last presentation. But I tell it to go to localhost. I tell it what type. Again, it has different types you can use. Other people have used it. I've heard you've used Elasticsearch for Telegraph as well, and I've liked it. I'm just not as familiar with it. And then you set up all your settings, and then you save and test it, and it says whether it's able. In this case, because I set it to localhost, it's not able to do it. But if I were to change it to the right IP address, it would work. So if we were in here and had that IP address, we would get it to work. But that's all you got to do to set it up. And I've got this Telegraph_internal to monitor the InfluxDB itself. So I set that one up separately because it has different tables than the SQL Server does. And I gave it a different data source name. So, but that's all you really got to do is when you add a data source is just fill this out and save and test it. Now we'll take a quick look at the dashboards and then we'll actually import a new dashboard, the most recent one that I wrote. So we can actually see how you get those in there. This is the main dashboard for SQL Server. So it gives you a nice instance overview of all your SQL servers. It tells you what your CPU usage is, your server information, what version of SQL you're running would be populated there normally. But I suffered these poor little machines at 2 gigs of memory. So I had 6 machines running in 16 gigs of memory. So this data goes back to November as well when I last had the snapshot running on it. So, and it gives you that current activity of the system. So you got user connections, transactions per second, batch requests. But when you've got multiple values in a chart, if you click on one, it'll show you just that one. Or you can hit control and click on 2 of them and show only 2. And then you can just click one and get them all back. So you're able to manipulate what you see on your charts very easily there. Then we had a problem with lock timeouts at a previous company, so we got a special chart just for that. I mentioned how we did weight stats. They're in here by the 23 categories by query store. So you can see they're very simplified: CPU, replication, translog IO, buffer latch. But I also mentioned the drill down. So if we go and drill down by instance, buffer IO was one of our top ones, and we can see the 3 different ones that are associated with buffer IO. We can also, if we want to see a different one, we can add CPU and see which CPU one it was. So you can click any one of these multiple ones that we had. Trying to remember, preemptive was on there as well, I think. It has all kinds of stuff it's trying to do on my OS system. So
that's great.
And then you can easily just click to another server as well on the same dashboard. And then I've got all the dashboards in a folder, so all the SQL ones are in the same folder. So when you're in a SQL Server dashboard, it'll automatically have all your other SQL Server dashboards to the side. So I've got the database size one is one that you can see, so you can see whether your databases are growing or not over time. This is every time I shut down my machine, it loses values and then comes back up. So, but you can see that over time, and like I said, you can decide which one you want to use. As I mentioned before, there's an interactability of drilling down. So if we wanted to drill down into this data, we could, and it readjusts the whole screen for you. So that gives you the nice benefit of being able to do that. But we'll go back to our instance overview because we only scroll down part way, and we didn't get to see everything it does before we continue. So now we've got, after our weight stats, we've got memory details. So it tells us what's being used up in our memory. So buffer pool is kind of the most important one. And because I only had 2 gigs of memory, other stuff actually takes up more memory. But I also keep up with SQL plans. And when I had a system that had hackathon, that was very important to see how much hackathon was taken up. So you're able to see this ebb and flow over time when you're running queries. You also have your memory performance. This is where I was talking about page life expectancy, where you can see it go up and down if you needed to. And we've got page writes and reads and stuff going on. We're also keeping up with our TempDB usage, because if everybody's using recommit and snapshot isolation, you might need to know what's going on in your version store and how much of that it's being used and how many temp tables are being created and not created and dropped and stuff like that. We're also keeping up with the latency from the disk. So this is directly to the Windows perf1 counters that we're collecting now, because we're combining the Windows perf1 counters and the SQL DMVs all in one chart, or one page anyways. So you can get the write and read latencies for all your disks. Your free space, we would have database size there if we had a longer time period. And then if we were running an AG, we would see AG stats here. So we were actually running one at that time. So cool. Yeah, we got AG stats. And then we do our log flushes. And then we had a lot of work that we did around resource governor that I'll show you some different charts on, but we have different charts for those. And there's a podcast you can listen to that talks more about how we had set those up. That's linked into my slide deck. But I'll show you the charts and explain those better when we're actually on that screen. So, but it's just kind of nice and interactive and very easy to use. So we created a low disk space one that tells us when things are at a certain percentage. We're able to just go into this chart and look and see which ones we need to look at. And then we've got our transactions per database set up too, so we can see. Why is it highlighted? Go away. Refresh. There we go. Now there's no data. Okay. Can I click on something? There we go. So it shows us all the transactions per database. So we don't have any user databases on this particular server, but we're able to see that data. And this is actually on my Linux machine, and I forgot to show you the difference between that and the charts on the instance overview. The only difference between the Linux machine and a Windows machine on this chart is how it shows the CPU data usage here, because the usage counters are different on Linux than they are on Windows. So it has in the background, this would be a good time to show you how to edit charts and edit queries. In the background here, you tell it what query to run, and I'm telling it if it's null not to show this. and if this is a null, not to show this. So it knows if I don't have no data for this server, don't show this, and if I do have data for this server, show that. So it just knows if it's Windows versus Linux, switch between the two, because the data does or doesn't exist for the server. So you're able to go in here and edit these queries, and you can put anything you want on these charts. And like I said, you can make your own charts and do things, and you can just, and it even just has a nice graphical interface for getting to the queries if you want to make them that way. But that's the only difference between using a Linux machine and a Windows machine on here, is it just knows based on the counters that it needs to change that, and everything else is exactly the same.
Those queries, that was InfluxDB queries, or is that?
Yes.
Okay, great.
Yeah, they're InfluxDB queries, because they've got like means and percentages and stuff like that. They're a little bit complex sometimes in the things that they do, because you guys select what measure in is actually a table. Gotcha. So we could pick our disk table, and the fields are actually fields this time, and you got to tell it what your where clauses are and things like that. So sometimes it's easier to copy and paste these and know what's in the tables, and then use this to figure out what field you want and change the field to what you want it to be. Because like if we looked at CPU, we got other ones that we could add in there if we wanted to see them, besides the 4 that I put up there. So if there's some reason we wanted to see something else, we could just copy and paste one of these fields and give it a nice, pretty name.
Great.
So I think those are all the SQL specific charts. Now, as I was mentioning, it does do SQL's Azure managed instances. So the SQL Cat team works on these charts here. This is not a managed instance, but if you point it to a SQL server, it'll populate data in there. So I don't have to pay for a managed instance to do a demo of it. But this is their HADR chart that they created that tells you what's going on as far as HADR stuff goes. And it's basically sort of the same charts we had before, except we've got a little bit more charts going on. This chart was in the other one. We didn't have this one. And they've got a few extra things going on that tell you things that are going on with those. So, and we had log flushes and these on our other charts. So, and of course, this is a weight stats just for HADR. And again, like I said, all these charts are customizable and drill downable and stuff. So you're able to do that fairly easy. Then they created a couple other managed instance charts. One was just like the overall performance chart that we were just looking at. It looks very similar to what we had, except you don't have server level settings. So most of that's been taken out, and you just got the SQL stuff going on.
It's a lot of stuff.
Yeah, a lot of stuff to play with and drill down on, and you're able to do anything you need to do. And hey, Quake.
Got the cat.
My cat wants all the attention, I think, today. I knew she was going to get into this. So, and then this tells you all about your storage as far as how you're using your database size, the stats on using the I/O, how fast it's being written and written to. So you're able to use all that to troubleshoot your SQL Azure managed instances. We're still working on dashboards for regular SQL Azure instances. So,
okay.
But you can also manage your Linux machines like at the operating system level. So in here, I've got just some basic measurements for a Linux operating system to see what the memory and throughput would be, what the CPU, what's going on my disk partitions and stuff. And with this chart, you're able to actually do multiple. If I had multiple Linux machines, you'd be able to stack them down here and see them together. So kind of nice. And then we can watch a Windows machine as well and see what's going on with it. So this was my domain controller for my AGs and what was happening with it while the AGs were running and the stuff I cared about on it.
Mm-hmm.
And then, of course, we would, we got to watch Influx itself because we're running on Influx. But this tells you everything that's going on in Influx and how many queries are running, how long they're taking to run, how many writes and reads and writes that are okay or failing, how much data is getting in there, how much memory it's using, how much is on the disk versus cache while it's using stuff, any errors it might be having, any latency it might be having on your disks that are showing up. So it gives you a nice, easy way to identify everything that you need to identify as troubleshooting goes. I think there's one SQL chart I forgot to show, and then we'll do an import. So I quit clicking so much. It's hard to do this via TeamViewer. Go away. I did this in Denmark on my Linux machine, and it was like so much easier to do it directly. I don't know what it's doing.
It's not liking you right now.
I know. What did I do to it?
The rest of the
Well,
desktop.
yeah, that's another machine, so it might have locked up. So, but we got through all the charts, so we just didn't see how to import one. So we'll dip back into the PowerPoint presentation.
Yeah.
So we did get through most of the charts there, and we just didn't see how to import one, and I can share that on the blog. So
Okay.
if we need to, because I would show that. So like I said before, the resource governor section on that main chart, we had ours separated out by, we had our resource governor set out by what application was logging in, could consume what resources, and we tracked what they were doing by CPU, by group, and then we had all these charts that could tell us what application was killing our server. So it was a pretty sophisticated setup. Mark Wilkinson, who I worked with, did a podcast with SQL Data Partners on how our setup is for this. So I have a link to that in my slide decks. But we also got a request per second by those groups as well. So we can see that, you know, this one group is hitting us at 2,000 times per second, whereas some of these are hitting us at 2.
Wow.
And we even had our maintenance stuff. If you see the bottom, the second to the bottom one is 25. So that's everything that the SQL agent ran. That was a DB maintenance job. So we knew when those were occurring versus a regular SQL agent job. So we could tell the difference between users doing stuff with SQL agent versus the maintenance stuff happening. And then we had one for when tasks were actually blocked. So this was sometimes some of those people were hitting 2,000 times a second and blocking a lot of other people's stuff. And we could tell who was blocking stuff and what was being blocked. So
that's great.
We will quickly show off the website links for how to install this stuff. So like I said, I have a guide on my website that's linked in the presentation. It's easiest just to go to databasesuperhero.com, and it's the top link on my popular post. But it walks you through this whole setup of doing everything. So it's got all the commands if you use Red Hat or CentOS to do it. If you're using the other Ubuntu's and stuff like that, of course, you'll have to change your yums and all that stuff to different install points. But it walks you straight through configuring Influx, Grafana, installing a Windows box, how to configure your output files. It provides you downloads for all the output files, so you don't even have to copy and paste them. And there's the PowerShell script. And here's how to set up the data sources, how to set up going and getting the dashboards, and a link to all the dashboards are here at the GitHub. And I have, this is a dashboard I was going to import that does database latency based on your virtual file IO stats, but we couldn't get in there to do that, so that's fine. And then I have an overview of what the main dashboard is, and then how to go about getting this on your Linux machine. And I have a couple other in the series just to get you started on monitoring the InfluxDB and monitoring Windows as well, because it does monitor a lot of different things. And then, like I said, Telegraph is on GitHub, and this is all the different things it'll actually monitor. You see it's got a nice long list of stuff besides just database stuff. We got CloudWatch, you know, I mentioned Docker before, Elasticsearch, if we went with Elasticsearch, Exchange proxies. It's got all kinds of stuff that can actually monitor. So, and people are adding stuff to it constantly. The only database I don't see out here that's popular, supposedly, is Oracle. Maybe there's a reason for that, but I don't know.
That's funny. Okay.
So the last part of the demonstration, Sharon, we didn't get to import to drafts, is this is what I did one day. When I was putting together this presentation, I was trying to think of, hey, how do I use this to solve a problem? And then I got paged. So I used it to solve a problem because I was actually putting the presentation together at a time when this particular page came through. So, and I was taking a nap. So I got this particular error message out of our Nagios system telling us this pocket timeout after 10 seconds occurred, which I'd never seen before. So like somebody, I'm not going to name who was in charge of our Nagios system had set up this alert and told no one about it and even what it meant. So I went and checked, and the SQL Server was online. I was able to connect to it. I checked again in 5 minutes. Everything looked good. I checked the normal stats. Everything looked fine. I couldn't see any particular reason to have gotten this page based on an initial analysis of it. So I just went ahead and went back to taking my nap. But when I woke up, this is what I noticed. When I went into Grafana and looked at this data, I noticed that my buffer pool had dropped by 44 gigs. So that said, oh, something ran. That's not good. So 44 gigs of data out of the buffer pool. And then I looked at my PLE and it dropped from 19 hours to 0 milliseconds. So at that exact moment, it just couldn't connect because there was it had a momentary blip because there was nothing in the buffer pool. So because I was having trouble keeping up. So I went in and looked into my SP who has active data to see what was running. And I got really mad then because it was CheckDB.
Yeah.
It's like, oh, CheckDB woke me up. So, so we actually changed the timeout to 30 seconds instead of 10 and stopped getting that particular page. And then, you know, I did an on-call selfie. I have migraines, so I have to sleep that way during the daytime with my headphones and my sunglasses on. So, but one question I get asked a lot is how much does this cost? Because, you know, it is open source, so it really doesn't cost anything but the hardware you're running it on.
Right.
Well, this is what it cost us to run it in AWS for 500 SQL servers. We had a T4 micro instance for our InfluxDB that had 8 CPUs and 32 gigs of RAM and 600 gigabytes of space. That cost us about $3,000 a year. Okay. And then Grafana costs us about $5 a month on a T2 macro because it doesn't require hardly any resources, just 1 CPU, 1 gig of memory. So for a little over $3,000, we were able to monitor 500 servers, and that include all our test and production servers, all in the same environment, consistent monitoring, all set up.
So 600 gigs of space with 500 servers. How much actual like daily data were you dumping into Influx?
I think we were dumping in about a gig and a half a day. I think was our metric with those. So, and we did set up some stuff where we were starting to do some retention policies on it, where it rolled up after a month. It rolled it up into 5-minute intervals instead of having it at the 10-second chunks, because we were collecting them at 10-second intervals there instead of 30 seconds. Okay. And those are future things I probably will blog about to help people with managing the space on this stuff. So, because there's not a lot out there about Influx or easy to find. I'd like to centralize it. So, but other than that, I don't really have anything besides links to how I got to all this stuff. So, you know, the SP who is active, how to use query store, getting SQL on Linux because Linux is cool, where to get Telegraph from, how to install it. I put a link to the WaitStats library out here, so WaitStats is pretty crucial in troubleshooting things, and then a link to the podcast where Mark talks about Resource Governor. And then I'll take any questions if there are any.
There weren't. I think people are just waking up. Not a lot. I have a few, only because I went through this whole thing over the last couple of years. We actually use Splunk in my company, so we didn't have one of the paid solutions specifically SQL Server. So we did a lot of the same thing you're doing with Splunk. But we started to investigate Influx and Grafana, and I like what they're doing. So when it comes to the DMVs and things you're monitoring, do you keep saying you did 30 seconds, 10 seconds. Do you look at, I would do things like, I might do 10 seconds on one thing and 30 on a different metric of some sort. Do you have any kind of feedback on what that looks like, or do you just kind of say, hey, 10 seconds for everything? And
well, yeah, with Telegraph just runs it at specific time intervals, so you can't tell each individual metric when to collect. Okay. So there is the ability to turn off certain DMVs in there. You can tell it like not to collect wait stats or database IO virtual file stats or something like that. If there's ones that you don't need for some reason and you want to speed it up, there's certain DMVs. There's a list of like 10 or 12 sections that you can tell it not to collect. That way you're collecting less if you don't need it.
So I guess you said you had about 600 gigs. So InfluxDB, you just you watched that and dump stuff out as you needed to. You said you kept stuff about a year.
Yeah, we had a default retention policy set to a year, and then we were exploring more of what we wanted to do as far as aggregating the data, so that you didn't have like the 10-second intervals after like a month or something. So, but we were able to keep that data for because if you if you don't, eventually Influx might slow down, and it's, because it just has so much to churn through to query stuff. So we were looking at ways to just keep it speedy with so many people querying it, because our VPs had access to query this data and look at these charts.
Okay.
Yeah, our VP over IT was looking at this stuff. So there was a company-wide, everybody was looking at the SQL servers in development.
Now I know you were an idea ace, and we have Aaron coming up next with SQL Century and all those. That's always the conversation, right? I mean, I actually, Tracy, I think I saw you maybe 2 years ago in Pittsburgh talking about this stuff. And we're in a similar situation. Sometimes the page solution is a good thing, sometimes it's not. What's your experience with the effort you had to put into this and the return on investment compared to installing something and just kind of letting it do its thing? Do you have any feedback on that?
Well, the Idea products and the Century One products and all of those, they do slightly different things than this solution does. This one just collects metrics, whereas they actually collect what queries are running. So it kind of depends on what you can handle out of the box yourself. So if you're more inclined to be able to do things yourself, and your company needs something that doesn't cost a lot of money, and you're able to interpret the data, this is a valid solution. If it's easier to install something and your company will pay for it, I have no qualms against a vendor product at all.
Yeah.
I've always worked at companies that wouldn't pay for them. So,
no, I get that. in a lot of cases, I'm there too.
Well, when you got 500 servers, you got to consider how expensive that would be. So,
yeah. So the Telegraph is the agent, and you said you had on 500 servers. How do you maintain and update? You pointed to, I think, a nightly build. So what's your process for going through?
I use the PowerShell script for that.
Okay.
I have
Just
the
every so
PowerShell
often.
script the same one I showed you will actually stop and start it if it already exists and replace it.
Gotcha.
So whenever you want to implement a change from Telegraph, you can just plop it in that network share folder and just send it out with the PowerShell script with all the servers specified that you want to update. Of course, try 1 or 2 before you update 500.
Yeah, that's awesome. Right, exactly.
Warnings in there for people, because some people, oh, an update, let's do them all.
That's great. And then I maybe missed a little bit. Are there any real differences? You showed some of the graphs of differences between Linux and Windows. Or any major, when it comes to SQL Server, are there any major differences right now with a solution like this as far as the information you get back between the two platforms?
No, all the DMV information is exactly the same. The only differences in the charts were the CPU and the actual the system level stuff, the server level stuff. The stuff you pull from Linux and the stuff you pull from Windows had to have 2 different queries so it knew which one to populate. So the data shows up differently, but it shows up in the same charts, and you don't have to go to one system to monitor Linux and one system to monitor Windows. Yeah,
that's awesome. That's a good solution. I appreciate you pounding this drum over and over again. I think there's so many people who just don't understand the value of just having this data. So
the easiest way to reach me is databasesuperhero.com. My email, my Twitter handle are all up on the side. But if you want to spell Boggiano, there's how to do it a couple times over. But that's the easiest way to find me. My presentation's probably already there from where I did it a couple months ago. I haven't changed it, but I will upload a new slide deck just in case. And it has links to the GitHub repository and, of course, the articles there. And then this is recorded for everybody's reference. So.
All right. Thanks, Tracy. Great job.